Hello everyone, I'm Frank and welcome to Frank Puzzles, and this is today's hard level difficulty puzzle. And it's called Dreams by Zibble. And here are the rules. We have chaos construction rules where we need to divide the grid into orthogonally connected regions such that each row and column contains the digits 1 through 9 once each. So what does it mean to be an orthogonally connected region? It just means that you can go from any cell in that region to any other cell in that region just by going through edges, all while staying within the region. So this is a valid orthogonally connected region because to get from this cell to any other cell in the region, you can just go through edges, all while staying within the region. This would not be a valid orthogonally connected region because to get from any of these cells to any of these cells, you would have to go through a corner or go outside the region, which is not allowed. And that's an example of how chaos construction rules work. We also have internal xsums, where a digit in a circle counts the number of cells it sees of its own region in its row and column combined, including itself. And region borders block vision. A number in the top left corner gives a sum of all digits seen. So, for example, these two digits would have to be essentially 4 because they would see 4 cells in this direction and this direction. Assuming this is the correct orthogonally connected region here, this would have to be 4, and this would have to be 4, because this sees 4 cells this way, and it sees 0 cells this way, going this way. Same with this. This sees 4 cells this way, and it sees 0 cells that way. This would have to be 4, and this would have to be 3. And the sum of these cells would have to add up to 10. Obviously, it's not going to work because... but let's use this one. The sum of these 4 cells would have to add up to 20 because it's the cells that are seen, and they sum up to the digit that's in the top left corner of the circle. And those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's go. Okay. 45 is going to be the easiest because those are both 9 and they see 45. The sum of the digits that they see are basically the entire region, right? So this must be 9. Interesting. This can go at most 1, 2, 3, 4. It cannot go 5 because if it goes 5, then these cells are in the same region. And this one would see that one. So this is at most 4 this way. Which means you have 1, 2, 3, 4, 5, 6. Let's go this way. This might be easier. Going this way and going this way. So... this must be some combination of 9 cells on the corner. So it could be something like... it could be all the way up to here, or all the way up to here. But it can't be... so it can't be the full one, because then all of these would have to be 9 also. Can't be the full one this way, so it must go at least this way. This is not the same region, because we know that... the 45 cage sees all 9 cells. It has to. Otherwise, it wouldn't add up to 45. So assume it's not this one. Then the problem is this one would have to be 8 cells here. This would definitely see more than 20 if that's the case. So it must include here. Can this not include here? Well, if that were the case, then it would see all 8 cells this way, and this would not add up to 34. So it must include this one also. So this one sees everything but at least 2 cells. So that means this is there. This sees everything So these two cells must add up to what? 11? 10. Because this sees all the cells in this row. This sees all the cells in this column. And this sees 9 total, right? So if this is 3 cells here, that would force this to be, say there was an additional 3 here. This would then see 4 cells total. So this would be 4. Oh, and also this is 20 plus 34, right? Well, I already knew that. So 20 plus 34 is 54, which is 45 plus 9, right? So see, double counts the 9, so that's correct. So this could be 3, it could be 4, it could be 5 technically. But if it's 5 seen this way, then this would also see 5 cells this way. And you'd have 2 5s in that region, which is not allowed. So this is 3 or 4, and this has to be 6 or 7 here. Okay. So this is 3 or 4. This sees 6 or 7. So it's at least 1, 2, 3, 4, 5, 6. All in the same region. Obviously, this cannot be going this way. These are all separate regions because this cell sees all the cells in its region. So it could be 4 this way and then 6 this way, or 3 this way and then 7 this way. This cell can only go 4 this way. So it could be 1, 2, 3, 4, 5, 6. So it's guaranteed to have these 3 cells being in some region because it cannot be all 5 here. If it's 5 this way, the problem is this cell would see more than just 3 cells this way. And this must see all the cells in this region. So it could be at most 4, 5, 6. It has to be 7, 8, and 9 guaranteed. So this is all the same region. Obviously, it cannot go that way because this cell sees all of the cells in its region. It cannot be the full 9 this way. Can it include this? Yes. It could. 7 and then 1, 2. Huh. This must see 2 cells, no matter what. So this has to see only 2 cells, and it sees a 1 with it. So it has to be 1 in one of these directions. And the reason why is to be part of an orthogonally connected region, you can't be separated by itself and just see itself when in the orthogonal directions. It has to see 2 cells, guaranteed. These are C1 through 4 to add up to 10. Oh, they can't see 1 cell. They have to be 2. So one of them's going to only see 2 cells. And again, you can't see 1 cell in the in its orthogonal regions, its horizontal and vertical regions, because you always have to be part of an orthogonally connected region. So you're gonna have to have a cell in an orthogonal direction, period. That means the remaining digits in this column are 1, 5, 6, 7, 8. So can this ever be 4 and 9? That means the remaining digits. So one of these is 2, the other one's 3 or 4. They don't have to be different regions. One of them would be guaranteed to be 2, so it would be 2 and 8. So there's a guaranteed 8 to be one of these two. Well, I guess 8 could be here also. It could be 2 and 8 there. If it's part of the same region, it could be 3, 1, 6. In fact, that's what it would have to be. Okay. If this is 3, this is obviously 3, 8, and 9 adding up to 20. If it's 4, 20 minus 13 is 7. So this would have to be a 1, 6 pair. So this could never be 5 or 7 here. If this is 3, this is 8. If this is 4, this would be a 1, 6 pair here. To add to 38, you either have 6 digits, 7 digits, or 8 digits. You cannot have 5 digits, because 5 digits add up to at most 35. 36, it's 6, 7, or 8 also. Interesting. This has to be more than this cell here. Right? Because so this, if it doesn't include the yellow, obviously if it includes the yellow, then it has to connect to the yellow, and it has to go that way. If it doesn't connect to the yellow, it has to go this way, because it sees at least 6 cells. And then the problem is that it must see at least one more cell than this here. This is 5, 6, 7. It cannot be 8, because 8 digits cannot add up to 35. They add up to at minimum 36. So this cell, no matter what, has to be connected to this cell. But it could be connected in part of this region, or it could be connected this way. And again, if it goes this way, obviously, this cell has to have more than just these cells, because this would only add up to 35 at most. So it'd have to go there, if that were the case. But again, this could be part of the yellow region. We don't know. Okay, so obviously this can't be part of the yellow region, because if it goes yellow there, this is much greater than 15. What about if we had 6 cells here? So what if it went something like that? Cannot be the full 7, so this is a separate region than this, definitely. Let's make that red. This can then see at most 5 cells, which is fine. So say we went yellow and yellow. Is that possible? This to see 23 with a 9 involved. I think the answer to that is no. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's not going to work. 23 with a 9 would at minimum be 1, 2, 3, 4, 5, 9, which adds up to 24. So that's not going to work. Therefore, this can go at most 5 this way. 1, 2, 3, 4, 5, 6, 7, 8. Therefore, this must be part of that region. So we're going to make this all blue, I guess. So this is all the same region. This is bordered here then. So this must go this way. This could see... So this is guaranteed here. This is bordered this way. And it's 1, 2, or 3 this way. If it's 3, and this is 6, this would have to be 1, 2, 4, but we can't have a 2 because of a 2 in the column. So it cannot be 6 this way. If it's 7 this way... So if it's 8 here, this is 7. Right? Because we're missing just 1 digit. It would have to... Oh, it cannot be 8. If this is 8 this way, again, you would have this already adding up to 23 with 6 digits. So this must be 7. So this sees 7. That's a border. So this is blue. And this is the full blue region. Obviously, 7 cannot be here. Say this was a different region than red. Then the problem is red would be stuck here because this has to see at least 3 digits, right? To add up to 38. Sorry, to 23. And if this is a different region, it can't go this way. It would have to go 3 that way. It would block the red. So this is part of red. These must add up to 7 because 45 minus 38 is 7. So it's 1, 6, or 3, 4 here. That means here we're missing 1, 6, or 3, 4, but neither of these can be 1 because if one of them is 1, that would say that, well, first of all, they're in the same region and they already see 2 cells each. So this must be a 3, 4 pair. Can this see 4 and this see 3? The answer to that is... Okay, so these include 7 already. This has to be 4 then. If this was 3, that would be 3 plus 4 plus at most 9, which is only 16 at most. So this must be 4, this must be 3. This only sees 3 cells, so it sees up to here. This sees 4 cells, so it sees up to there. This cell cannot be red because this cell only sees 3 cells. So 3, 4, and 8 add up to 15. Therefore, this must be part of the light region. So this is light, which means this is a full 9 cells in the light region there. So this is done, this is done. This only sees 3 cells. So this sees 3, this must see 7 to add up to 34. And this must be 3 and 8. So there's no 8 here. Which means 8, again, has to be one of these 2 digits to be with the 2. This 7 eliminates 7 here. This sees 5 to 6 cells. It can see at most 1, 2, 3 here. This is done as a region here. So then 1, 2, 3 here. This is guaranteed 4, 5. So these are definitely all part of the same region. This cannot be 4 here because it would see... Oh, it could be. 4, 2, 1, 3. No, because it only sees 2 digits. These... So if we try to have a 4, if we tried to have a 4 and 2 be in the same region, the problem is the 2 would see 2 and 4, and it would see another digit. And that's not possible, because it only sees 2 digits here. So these must be separate regions. And if we try to have this being 4, the problem is it would have to see, well, I guess it could be 4, 1. That's possible. But then the problem is if it's 4, 1 this way, right? 4, 1, 2, 3. The problem is 2 would only see 2 cells this way and would have to turn, which is not possible. So this cannot be 4. This is 2. This is 4. This sees 4 this way, and then it sees an edge. So this has to see 5 cells here. So this is all orange, which makes that an orange because there's no other cell it could be part of. So this sees 5. This sees 2 digits. And then it's done. So this is border there. This is border here. This has to be an 8. So this cannot be 8 here. So this must be 1, 2, 3. To add up to 10 that it sees. This is not the same region as this. So this is done here. And this must be medium gray. This cannot be 8. It's 6 or 7 here. This is likely part of orange. This has to be what? Remaining digits are 6, 7, and 9. To add up to 35, it's 8. It's 6, 7, and 9. So this must be 1 through 4. It cannot see 1 digit, so it's 3 or 4. To add up to 23, it cannot be just 3 digits. If it's 3 digits, that would be 3, 8, and 9, adding up to at most 20. So this must see 4 cells, which means this is orange. And to add up to 23, this is 12. That means the other 2 digits must add up to 11. Is that right? Oh, we have an 8 here. Oh, no, sorry. Oh. Okay, so this is 6, 8, and 9. I don't know how I got 6, 7, and 9. That leaves this as 7. Okay, that's better. So this can't be 7, this is 6. This has to be 3 or 4. Again, 3, 7, and 9 add up to at most 19. So this must be 4 digits. 4 and 7 add up to... So this has to be a 3, 4 pair. This can't be 4, so this is 3, this is 4. 8 eliminates 8 here. 4 digits. We have 4 and 7. That's 11. So the remaining 2 must add up to 12. So this can't be 6. This is 9 because it would have to be 6 and 6 to add up to 12 with a 6. And this must be orange, and it sees that. So this is border here. So then this is 3. Well, we have 1 and 2. This is not part of the region. It has to go here. And it's very likely there. It could be either one of these, though, technically. Remaining digits in column 8 are 1, 5, and 9. Obviously, this can't be 9 because of 9 in the row. This is a separate region. So this is done as this is a border. We're gonna make this, I guess we'll make the light, instead of the light, we'll make it green. And then we'll make this light. This has to go out somewhere, so we'll go that way. Excuse me. Remaining digits in row 9 are 1, 2, 5, 6, and 8. So this adds up to 23. This is the border here. So 3 and 4 add up to 7. 23 minus 7 is 16, so 2 digits adding up to 16 must be 7 and 9. 9 can't be here because of 9 in the row. So this is 7, this is 9. Remaining digits in column 1, we have 1, 2, 5, 4, 5, 6. No 6 here. No 2 here. No 4, 5 here. So 1, 2, 6. Remaining digits in row 8. We have 1, 2, 5, and 6. Obviously, this can't be 1. This can't be 2 digits to add up to 29. So this must be 5 or 6. Therefore, it can be at most 4 this way because it can't be part of the red region. Or could it be part of the red region? One, 2, 3, 4, 5, 6. That's 21 plus. It could be part of the red region. Okay. Remaining digits in row 7. We have 1, 2, 3, 6, and 8. Okay. Remaining digits in column 2. We have 1, 2, 3, 5, and 6. No 2 here, no 3 here, no 6 here. The circles cannot be 1, obviously. They cannot be 2 either. Because 2 and another digit is adding up to at most 11, not 16. Cannot be 3 here, because 3 plus 8 and 9 only add up to 20 at most, so this is 5 or 6. This is 1 or 2. It obviously cannot be 2, because of 2 in the column. So this is guaranteed to be 1. We need access to a 2. So one of these is a 2. Obviously, it would work very well if this was 2 and this is 1. So this can't be 1 anymore. This can't be 1. Remaining digits in column 7. 5, 6, 7, 8. No 8 here because of 8 in the row. This can't be 6 because of 6 in the row. This can't be 7 because of 7 in the row. This sees 6 cells. You can see at most 3 this way. So 1, 2, it could be 4. 1, 2, 3, 4 technically. Then 5, 6. Right? So we know these 3 cells are the same region. Because if it's not, if this is not the same region as this, that'd be 1, 2, 3, 4, 5 cells that it sees, which is less than the amount allowed. So we're going to mark that as pink, but it probably is part of the dark region would be my guess. Wait, can it be that way? So say it's part of the dark region and is 6. Well, okay. So say it went this way. The problem with that is that... Okay. What happens if it's this? So obviously the dark has to go out somewhere here because it's blocked by this medium gray region. And if this is a different region than the dark, the only way this is 6 and doesn't block the dark is if it goes this way, at minimum. It can't be the full 6 going that way, because then these would add up to 16 and 36. But the problem is, if it goes this way, and this is part of that region, then These 5 would have to add up to 18, and 18 plus 9 does not add up to 36. It's 27 at most. So, we assume this was not part of the dark region, and the only way that works is if it's here, but it doesn't really work. So then this has to be part of the dark region. So it sees 1, 2, 3, 4. It cannot be the full 6 this way. So one of these 2, at least, has to be part of the region. And the 6 that it sees here, whichever way it does, it must add up to 36, which means these 3. So this sees 6. That means the remaining 3 it doesn't see are here. And that must be not 1. So it's 2, 3. So this adds up to 9, and the rest add up to 36. 9 plus 36 is 45. So this is 1. It could see both of these. It could see up to here, but it does not see up to there. So this is 5, 7, 8, 9. It must include at least one of these. We don't know which, or it could be both. This is obviously not a boundary here. This cannot go 2, 1 this way, because if that were the case, then it doesn't have a place to go. Can't go be part of the dark region, can't be part of the orange region. It can't go out that way because it goes that way. So assuming this is not dark, it would have to be part of this region because it can't be part of orange because this only sees 4. And again, it would be 2 and 1, and then this couldn't go out anywhere else, so that wouldn't be a full region. So this has to be dark, which means this cannot contain a 1. It's 5 or 9 here. And it either includes this or includes that for the region. Probably this, but we don't know. So this is separate from this region here. This is separate. So it either goes there or it goes there to see 6 cells here. Because this sees 4 cells that way. Okay, orange can go either here or here. If orange goes here, the problem is that this sees only 2 cells this way, and would have to go here and then down because it can't go up because it's blocked by the dark. But that doesn't work, so this must be orange here, which means this is not guaranteed to be 1. We have the full orange region. It's there. Okay. 1 cannot be here. Remaining digits. This adds up to 18, so it's 2 through 5. Cannot be 1 or 6. Remaining digits in row 4 are 2 through 9 without the 6. No 3 here because of 3 in the column. Okay. To add up to 19, no, this can't be 2 either. 2 plus another digit never adds up to 18. This is 3, 4, or 5 to add up to 20. This is 3, 4, 5 to add up to 19. Because to add up to, if you have 6 digits, that would be 21. So the orange region's done, the blue region's done. The green region's done. The dark region's kind of done. Let's see. To add up to 16 cannot have a 6. You can't have 5 either. If you had 5, the problem is that 5 by itself would mean that the other 4 digits it sees would have to add up to 11. 16 minus 5 is 11. And then the problem is the only way you can have 4 unique digits adding up to 11 is 1, 2, 3, and 5, which we already have the 5 there. So this cannot be 5. This is 3, which eliminates 3 here. This is 2 and 3 there. This cannot be 3. There's no more 3 in column 2 either. This can't be 1 because of 1 in the row. We have a 2, 5, 6 triplet in column 2, which eliminates 2, 5, 6 in the rest of the column. This can't be 2, 5, or 6. This is 1. So this cannot be 1 this way. And if this includes this cell here, the problem with that is 3 and 1 only add up to 4. With another digit, that would add up to at most 13. So this cannot be, this has to be then not part of the same region. This sees at least 5 cells this way. So this is likely going, this has to go here at least for 5 cells. This is likely part of light, I'm guessing. It goes, sees 3 cells, and then it cannot go any further. So this is boundary here. What happens if it goes this way? 1, 2, 5, 6. 1, 6 is 7. 2, 5 is 7. That's 14. Huh. Interesting. To add up to 16, 16 minus 3 is 13. So that means this is 4, 9, 5, 8, which it can't be because of 8 in the row, or it's 6, 7. So this is 4, 9, or 6, 7 this way. To add up to 16. So this is done. 45. We have 9 cells, which add up to 45. 3 cells adding up to 20, which is done. 2 cells adding up to 10, that's done. 4 cells adding up to 10, which is done. 5 cells adding up to 35, which is done. 7 cells adding up to 38, which is done. 4 cells adding up to 23, which is done. 3 cells adding up to 15, which is done. Say this is 5 or 6. Well, that's not helpful. Never mind. This cannot be part of this region here. If it is, then this region is only going to be 4 cells long, and that's not possible. So it can't be part of this region, obviously can't be part of this region. So this is at most 2 cells this way. Say it's not part of the dark region. It has to be, or the medium region, sorry. If it's not part of the medium region, it sees at least 4 cells. So the problem with that, then, is if it's 4 cells this way, the medium region has to go out there, but then it blocks off the light region, and that wouldn't be valid. So this has to be part of the medium region, then. Remaining digits in row 3. We have 2, 4, 5, 6, 8, 9. So this is not part of the dark region, or sorry, the medium region, because this only sees 2 cells. So that means this is at most 1, 2, 3, so this has to be medium this way. Guaranteed. Dark can be 1 here or 1 here. We're not sure. So, and this cannot be medium. Okay. So this is definitely medium. And because this is medium, this cell cannot be dark. It has to be, sorry, cannot be medium. It has to be dark. So then this is dark, which fulfills that region as a region because we have 9 cells. 1, 2, 3, 4, 5, 6, 7, 8, 9. This becomes a 5, 9 pair, which eliminates 5 and 9 in the rest of the column. This can't be 5. This is 1, which eliminates 1 in the rest of the row. This 5, 9 pair eliminates 5 and 9 in the rest of the dark region. So this becomes a 7, 8 pair, which eliminates 7, 8 in the rest of the row. So we know there's a 3 in one of these 2 cells. This has to be medium to fulfill that. So it can either go 4 that way. I guess it could be 5, right? So this cannot have an 8 because it's in the medium region. So this is a 5, 6, 7 triplet, which eliminates 5, 6, 7 in the rest of the column. This can't be 7. This is 8, which means this can't be 8. That's 7. That eliminates 7 here. We have 1. Okay, so this cannot be 2. It cannot be the full 2 this way because then it would include a 2 guaranteed. So this is not medium. Medium could go up to here. We don't know. Can you add up to 20 for 4 digits? So we're trying to have that not be medium. You can't go the full 5, because if you have the full 5, you include another 2 in the medium region when we have a 2. So it can only be 4 if this is not part of the medium region. And like I said, 2 eliminates 2 here. So if this is 4 going this way without a 2, that's at minimum 4, 5, 6, and 8. It can't have an 8 here also. So the answer is it cannot go full this way. Yeah, it can't just go 4 this way. Because if it goes 4 this way only, it would have to be at minimum 4, 5, 6, and 9, which adds up to greater than 20. Because it can't have 2, can't have 8. Oh, that's another thing. Oh yeah, this can't be 8. So we have a 4, 5, 6, 9 quadruplet in row 3, which eliminates 4, 5, 6, 9 in the rest of the row. This is a 2, 8 pair, neither of which can be in gray. So then this must see 4 digits, and it must include this. The medium gray needs access to a 3. And again, it's blocked here. So this sees 4, it's blocked here. This sees 3. If it's not light, the problem is light would be at most 5 cells, so this has to be light. So this is light, which means this can't be light. This is medium as the remaining digit. So this is full light, 1, 5, 6, 7. This can't be 6, 7. This becomes a 4, 9 pair. We need access to 2 and 8. It's very likely both of these. This can't be, this is 3, 4, 5. It cannot be part of light. So this is guaranteed to have a light here because it can't be 2 lights this way. This is done as a region. No more 4 here. because we have 3, 4, 9 here. This is 1, 5, 6, 7, so this can't be 3, 4, or 5 as a light region, so it's either 2 lights there or 2 lights there. We're not sure which one. This needs access to a 3. It must go out here. 1, 2, 3, 4, 5, 6, 7, 8, and that's the 9th cell. So that's done there, and this must be a 3. Because the medium doesn't have access to a 3 otherwise. This 4 eliminates 4 here. No 3, no 3. Three cannot be here. Remaining digits in the medium gray region. We're guaranteed a 1. 1, 5, 6, 7, or 9. No 7 here, obviously. 1 has to be one of these two, so this can't be 1 here. This is 5 or 6. No 9 here, no 9 here. Where's the 9 in this region? Because of the 4, 9 pair in the row, it has to be here. So this is 9, which means this can't be 9. That's 5, that's 9. 5 eliminates 5 here, so it's 6. Which eliminates 6 in the rest of this region. This becomes a 1, 5, 7 triplet, which eliminates 1, 5, 7 in the rest of the row. This can't be 5, so this is 6, which eliminates 6 in the rest of the column. This 6 eliminates 6 here. This is a 5, 7 pair. Okay. So this still could see 6 here, and that would be valid, because that adds up to 29, with 6, 7, 8, 21, and 1, 2, 5 adding up to 8, which is 21 plus 20 plus 8 is 29. 1 cannot be here because of 1 in the row. We're left with red, yellow, and pink. Can this be non-pink as a region? Well, it couldn't be light. So say we had this as yellow, as a different region than this. Then the problem is this would have to see 5 cells. It would have to be 5 cells at least this way. And it would block the yellow from forming a 9-cell region. So the answer to that is no. So this must be pink then. This is at least 1, 2, 3. It could be 4 and then 5. That is possible. Where is 9 in column 6? Can't be here because of the 4, 9 pair in the region, 4, 9 pair in the row. This is already filled. This can't be 9 because of 9 in the row. These can't be 9 because of 9s in the row, so 9 has to be here in column 6. Where is 9 in row 4? This is a 2, 4, 5 triplet, so this must be 9 here, which means this can't be 9. This is 4, which means this can't be 4. That's 9. No 3 here because of 3 in the column. Interesting. So this cannot be part of the medium, sorry, of the light cells. So this must be the other light cell. And it's 2, 8. So that's done as a region. Can this be another region here? If it is, it would have to only see 4 digits, which is possible. Then this would have to see 5 digits. Which is also possible. 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so say this was... Okay. Say this was another region. If this was another region, the problem is this sees at minimum 4. And then the pink, how does the pink get access to a 9? It has to get around this region. This sees at least... If this sees 4, say it sees 5. The problem is it can't go around. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it's too large. If we try 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, it can't reach this one, so this is pink. But if this is not pink here, this is a separate region. It sees at least these 4. The problem is this would be at most 4 digits there, and 4 here going this way would mean this is a 10-cell region, which is impossible. So this has to be part of pink. So this is part of pink. This sees at most 4, so this is pink. So this could be part of pink. This sees, it cannot see 5 cells this way. If it sees 5 cells with 9, that's at minimum with 1, 2, and 3 also. So 5, 9 is 14, plus 6 is 20. So this has to be 4. So this is 4. Cannot see 4, 9, and 5. That already adds up to 18. So this has to be 4, 9, and 2. So this can't be 2 or 4. This is a 5. So 2, 9, and 4 add up to 15. That means it's with 3 here. So this is 3. This is done as a border there. No 5 here. This is 1, 4, 2, 4, and 1, 2. Can this be 5 anymore? 1, 2, 3, and 5 does not work. Because that would be add up to 11, and you'd have 1 digit adding up to 24 minus 11, which is 13. So this sees 6, which makes this 5. 6 eliminates 6 here, so that's 8 and 6. So we have 1, 2, 6, 3. If it sees this way, this is guaranteed to be 5. Actually, could it be 4? Maybe. What are the remaining digits here? No, 1, 2, 3, 4. It's 5, 7, or 8. Cannot be 8, so this is 5 or 7. What are the remaining digits in row 5? Well, this can't be 4 or 7. It's 1, 4, 5, or 7, so this is 1 or 5. Where is the 7 then in row 5? It has to be here. So this is guaranteed 7. If this is pink this way, this is guaranteed 5. So 1, 2, 3, 5, 6, 7. If it's pink this way, this is guaranteed 5. So either way, it's guaranteed 5, which does add up, I think. So 2, 3, and 5 add up to 10. 1, 6, and 7 add up to 14. 14 plus 10 is 24. So that's valid. If this were pink going this way, this would be 5, and this would have to see an 8 also. And that's not going to be possible. Right? And that would be 5, 3, 5, 6, 7. That already adds up to 21. Which is greater than 19. So this cannot be part of pink. This must be part of pink. This is part of the yellow region, then. It cannot be red. Because if it tried to be red, this would see... It just wouldn't work. Right? Try to connect it, right? Okay, so this has to be pink this way. 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is done here. If this is red, this would just not work. This is at least 1, 2... This sees at least 4. So then it would be at least 4 cells here, 5 cells here, and there's no way they can connect. So either way, this has to be yellow here, right? If we try to make this a red, it's just too far to get around. So this is yellow. This is done as a region. This is 8. So that means this can't be 8. This is 2. That's 8. So no 2 or 8 here. No 2 or 8 here. No 2 here. No 8 here. No 8 here. This has to be yellow. Cannot be red. This sees at least 4, so this is yellow here. This sees at most 4 this way, so this has to be yellow here. So either all of these are... We have 1, 2, 3, 4, 5, 6. We have 3 at most. So this has to be red here. So this is red or yellow. We're not sure. And these are red or yellow. We're not sure. Okay. Remaining digits in... If this were 5, that would force this to be 6 here. And we'd have a 1, 7 pair here. Remaining digits in row 6. We have 2, 4, and 7. 4 cannot be here because of 4 in the column. No 3 here because of 3 in the column. We have a 1, 2, 6 triplet in row 7, which eliminates 1, 2, 6 in the rest of the row. So this can't be 1, 2, or 6. This is 8. This can't be 1, 2, 6, or 8, so it's 3. If this were a 5, then this would guarantee this is 6 and this is 1. 1, 5, 6, and 8 already add up to way too big of a number. 5, 6, and 8 already add up to 19 by itself, plus 1 is 20. So this cannot be 5, this sees 4, which means there's a boundary here, so this must be red. Which means this is red. This could be red or yellow, technically. But to add up to 5, it doesn't work. It has to be all 6. So this is 6. Therefore, this is red. So we have all the reds here. This can't be red anymore. This is yellow. So these are the borders. 4 eliminates 4 here. 6 eliminates 6 here, and 6, no 6 or 8. 4 eliminates 4 here. This is 1, which means this can't be 1. That's 2, which means this can't be 2. That's 4. 1 eliminates 1 here. It's 5. 4, 5, and 8 add up to 17. So that's plus 2 to add up to 19, which means this can't be 2. This is 7. 2 eliminates 2 here, so it's 5. 5 eliminates 5 here, so it's 6. This can't be 5 or 6, it's 2, which eliminates 2, 5, and 6 here. That's 8. This 5 eliminates 5 here, so it's 1, which can't be 1 or 5. That's 6. This can't be 1, 5, or 6. It's 2. No 2, 6 here. 6 eliminates 6 here, so it's 1, which means eliminates 1 and 2 here, so it's 6. 1 and 6 cannot be here, so this is 5. This can't be 2, 5, or 6, it's 1. No 1, 6, or 7, it's 5, which eliminates 5 here, so it's 7. 5, 7, and 1. Ah, some lovely dreams to end a fantastic day. Hope you enjoyed as much as I did. I did, actually. I love chaos construction puzzles. They're just so much fun, actually. The logic behind it can be widely varying, and it's just fun to color things, I think. So maybe that's part of it. Anyways, I hope you enjoyed this solve, and I'll see you next time on Frank Puzzles. Take care.